guys are going to be applying your skills with solving inequalities that you learned in the last video to word problems. You're going to be defining variables. You're going to be looking for keywords like at most and at least. Please make sure to copy down the 3 example solutions. You don't have to do the actual words, but definitely the solutions to all 3 of the examples in this video. It shouldn't take that much time. And if you have any questions, let me know. So you've learned how to solve inequalities, and now we're going to apply how you solve inequalities to word problems. So the key words for the inequalities are, when you're reading a word problem and you see the words at most or no more than, you have to think less than or equal to. Because I can make at most $60, which means I could make 60, or I could make 59, 58, 57, etc., but I can't make over that. I can make at least $60. That means I can make 60 or 61 or 62 or 63, but I'm not going to make less than 60. So at least is greater than or equal to. So I know it's kind of counterintuitive because you're thinking at most should be greater than, but it's the most amount of money you can make, or the least amount of money you can make. So the least amount of money you can make is $60. $60 has to be included in that solution set. Less than or fewer than, those are pretty commonplace words. Less than, so you're just going to be the less than sign. And greater than or more than, it's just going to be the greater than sign. It seems that these two kind of trip people up because you're not thinking all the time of what does that mean to me. So let's look at how it can be applied. So in this case, Richard has $500 in his savings account at the beginning of the summer. He wants to have at least $200 in his account by the end of the summer. He withdraws $25 each week. So I'm going to write an inequality to represent this situation. And just like every other inequality and equation that I write, I'm going to define my variable as let x equal number of weeks. Because when I put x into my inequality, it's going to represent how many weeks he can spend money. So Richard starts with $500. So in his savings account at the very beginning, he has $500. And he wants to have at least $200 in his savings account. So we know that based on the slide before this, at least means he has greater than or equal to $200. So the least amount of money that he can have in that account is $200. But he can have more than $200 and be completely fine. And each week he's going to withdraw $25, and we don't know how many weeks that's going to take him. So 500 minus 25x is greater than or equal to 200 because he's starting with 500. He's taking out $25 per week. We don't know how many weeks, and he needs to have at least $200. Now, the second question says, how many weeks can he withdraw money? So basically, you're going to solve this inequality the same way that you've solved every other inequality. You're going to subtract 500 from both sides. You're going to create a zero pair. You're going to get negative 25x is greater than or equal to negative 300. And you're going to sit there and you're going to go, okay, so now it appears that I am dividing by a negative. Okay, so I need to make sure that I flip the symbol, and I should get x is less than or equal to 12, which should make sense to you right now because the most that he can do, the most weeks that he can spend $25 is 12 weeks, but he can spend less. He can work for less than 12 weeks. He can work for 10 weeks, and if he worked for 10 weeks, then he would have $50. He would have $250 left in his savings account, which is fine with him. He just needs to have more than 200. So in this situation, yellow cab charges $1.75 flat rate. You get in the cab, you're automatically spending $1.75. Whether you go 2 feet, 200 feet, 200 miles, you're paying $1.75, period. And then they spend 65 cents per mile. Katie has no more than $10 to spend. So she's got $10 in her pocket. She gets into a cab. She knows right away she's spending $1.75. She needs to write this inequality. So she's going to spend 65 cents per mile. So we're going to say let x equal number of miles That is an ugly looking X. Let X equal number of miles. So she's going to spend 65 cents per mile plus $1.75 as a flat fee. And she can spend no more than, so the most amount of money that she can spend is $10. So now we need to figure out how many miles Katie goes. So we have the inequality that we've already created. And if you don't want to include that 0 in front of the 65, that's fine. You just need the decimal point. Plus $1.75 is less than or equal to 10. We're going to subtract $1.75 from both sides. We're going to get 65 cents is less than or equal to $8.25. And then you're going to do that really, really fun division. So I'm getting out my handy dandy calculator only because I don't want to spend 25 minutes with you guys trying to figure that out. So I'm going to do $8.25 divided by 65 cents. And I'm going to get a funky number where X is less than or equal to 12.69. I know that I'm going to pay 65 cents per mile, so the minute that I go over 12 miles, I'm going to be paying another 65 cents. And since X is less than or equal to 12.69 miles, basically I know that the most amount of miles that I can go is 12. I can't go more than 12 because the minute I go 12.01, that cabbie is going to charge me that extra 65 cents, and then I'm going to be over my $10. So 12 miles is the most amount of miles that I can go. So now let's apply inequalities to one of those let statements defining your variable equations that you did. Alex sells 4 more than twice the number of candy bars as Samantha. I know that I need Samantha's amount, so let X equal Sam's candy bars. And then I'm going to say that 2X plus 4 equals Alex's candy bars. So I know that together they have to sell at least 40 candy bars. So I know that at least would be greater than or equal to 40. So for whatever reason, they have to sell at least 40 candy bars. Their minimum amount they can sell is 40, but they can sell 100 and all is good in the world. Together, so that would be Sam plus Alex. Has to be greater than or equal to 40. 3X plus 4 is greater than or equal to 40. I'm going to minus some 4 on both sides. Get 3X is greater than or equal to 36. Divide by 3 and I get X is greater than or equal to 12. That basically means that Sam can sell 12 candy bars or anything more than 12. So when the question says what is the least amount of candy bars that each girl must sell, well, Sam must sell 12, but she can sell 500 and all is good in the world. And then Alex must sell 12 times 2, which is 24, and 24 plus 4 is 28. So Alex must sell at least 28 candy bars. So Sam's smallest amount is 12 and Alex's smallest amount is 28. But the girls, if I were to write an inequality to express how much of candy bars each girl could sell, it would be X is greater than or equal to 12 and X is greater than or equal to 28. And again, I'm going to check my work by doing 12 plus 28. That's going to give me 40. And I know that X can be greater than or equal to 40 because the girls must sell at least 40 candy bars.